Number 4. Could you explain Thomas Zurbuchen, NASA's Associate Administrator for the Science Mission Directorate's statement on the picture below? As Webb aligns and focuses over the next few months, these 18 dots will slowly become a single star. And George is saying, why not just show the full star at once with these pictures? Does it have to do with how the telescope was designed, or is it something else? We touched on this a little bit, but there are 18 panels of the primary mirrors. So on each of these, those dots that you're seeing, each one is going to get a dot. And then those images from those 18 are going to reflect off the secondary mirror into the devices on James Webb. So when they're getting those images, this reflection is reflecting here. So you're getting those 18, and then what Webb has to do is they have to focus all of them in to a single point. Now what this does, as opposed to a single mirror, right? A single mirror, you just get that one view of whatever your light you're taking in. If you have 18 of these and you're able to dial them in, you're almost getting the animations of this are crazy, and I'll attach this link and we'll add this video real quick, time lapse of what they did to dial that in. You're getting so much more of one point of light. You're getting these 18 different minor adjustments, and you're getting a fuller piece of data of that piece of light. So that alignment that he's talking about, those 18 dots, are becoming a single star. Now, why they showed it is a good question to ask. It's definitely not something that I think this is like they're trying to explain the science behind how James Webb Space Telescope works. So I think in the context of what Dr. Z is bringing up here, it's the reason that they're showing the 18 is that they wanted to promote James Webb Space Telescope. They wanted to show people what's involved in the process. And I think that's why that picture came out and not just the full star. Because I guess you could also argue what's so interesting about just one star. And they were also engineering images, right? Those were dialing in, calibrating James Webb Space Telescope. So you're kind of getting a glimpse into what the engineers have to do to get from an observation to basically where we get these images that just came out, right? You know, each of these mirrors are adjustable. Their angles can change to reflect the light and focus. So the cool thing is that with these 18 primary mirrors, you can refine for distance, for exposure. Like, there's a lot you can do, and since all of those mirrors are changeable, you've got that. There's also the advantage that these 18, they kind of plan for the fact that if some micrometeoroid hits one of these panels, that means they've got 17 more, right? So there's kind of like a slush of damage soak that this telescope can take, that if it was one giant mirror, you get a crack in it and the whole thing's ruined. So there's also a redundancy to those mirrors that's kind of important too.